Great. Well, we're live.
We are absolutely. It's great to be here.
Yeah, this is pretty astonishing. It's taken a lot of work to get to this point.
Yeah, I hope it all coming through really clear.
All right. Well, g'day. We're on YouTube and Facebook at the moment. This is our very first Magus Meet. I'm Graham, founder of Core Electronics. This is Tim.
Nice to meet you guys. Yeah, nice
Tim,
to be here.
Yeah, Tim's helping out with a bunch of 3D printing type activities at the moment and doing some great maker guides, and is a local here in Newcastle. So we're on the same shift here at Core, and we're basically doing some live streaming throughout the week as well. And this is our first Makers Meet that we've been working hard to get this studio all together. So I guess a little bit of a heads up of where we're going with this. We'll be running some workshops throughout the week, maybe 1 to 2 a week, and besides that, we'll also do 1 to 2 maker meets a week, and we'll ramp it up as people show interest to it, or want to explore other interest categories. Thanks, Ramya. Got your chat here from YouTube. In fact, all going well. Let's say hello. Great, nice. Yeah,
yeah.
Cheers, mate. That's the first comment on our live stream. So we may as well get started. So what better place to start, Tim, than having a look at what you've been working on?
Absolutely, I'd love to show you guys.
Yeah, well, here we go. May as well kick on with this guide here, hey?
So I've been lucky enough to use a whole bunch of the Ultimaker 3D printers that we have around here. And they're such a treat, and there's so many things that you can do with them, there's so many things you can build with them.
And there's the mouse.
And there's so many different types of materials that you can create any kind of design, almost any kind of prototype. You can really use them as a very functional tool in any kind of workshop.
And so this guide's about material compatibility with different machines, because there's like 4 or 5 main machines that are still quite popular. But there's also a few others that are more legacy machines, and there are some quite new materials, right, that don't work on all the machines.
This is absolutely true. So it's worthwhile figuring out exactly which ones you can use your certain printer, which materials you can use exactly for your printers. So I started off just talking about how with Ultimaker, they produce their own particular type of filaments, and those kind of filaments, if you use the Ultimaker machine, and they work not experimentally but perfectly, then you'll be able to print exactly what you want to produce straight away. There won't be any kind of errors or anything like that. It's much more reliable, particularly with the newer machines. So if I scroll down, this table, this is where the meat of the information is. This is where you want to be looking. So when we have the different kinds of printers, so we have the Ultimaker S5, S3, the Ultimaker 3, the 2 Plus Extended, which is a taller, more space to print with, the 2 Plus, and the original, and that's the machine that everyone knows when you see an Ultimaker. That's the one where it's been laser cut wood. These new machines, and that must have been like 2011 when that came out, because I must have just started university. That's when I first saw them, first got my hands on them. The S5 and the S3, that's more like 2018, 2019. So they're much more recent machines, and the things that they can do that the previous generations of machines weren't able to do is almost astounding. So there's lots of different materials you can use, especially for the S5 and the S3. So we're talking PLA, tough PLA, ABS, nylon, CPE Plus, which is slightly harder, slightly more firmer, but less. It has a capacity to shatter easier. You also got PC, TPU, which is more of a kind of rubber material. You've also got PP and the breakaway materials, which are the PVA and the breakaway listed material. So it's interesting to see, particularly with this, the ones that are experimental, the ones that you need to put a little bit more effort in to make work.
And experimental meaning you can load it up in Ultimaker Cura, though some profile adjustments needed, right?
Exactly. Yeah. You might be able to get a perfect print the first time, but it's more likely you'll need to work at it just a little bit more. But the S5, it's remarkable. You tell, like, the machine knows automatically what kind of plastic or what kind of filament you're using
through the RFID in the reels as you're loading it. In fact, I'll bring up a picture of the machine here.
Yeah.
Well, I mean, there's a picture of an Ultimaker. I'll get my head out of the way. But on the back of it are where the reels are loaded, and as you load them, there's an RFID chip inside, and that way the machine knows what's fitted. So as you send that job through from your slicing software through to the printer, you'll find that if there's any misconfigurations, the printer will hold you up and ask for that material to be changed over. But that ensures that the whole production cycle from idea to, from concept to some preparation for 3D printing and going into 3D printing the object itself, a lot of the risks and variables are just taken out of that. So this compatibility matrix really does, and it's hard to find content like this. It's like almost the job of the maker industry to sort of collect this and not just the new stuff, but the new and the old stuff, along with just little points about not just not compatible but experimental, that help people get over the line with what machines work with what material. And the S at the front of the number for Ultimaker S3 and S5 means it's part of the S line series. So even though the Ultimaker 3 is compatible with all these materials, the S line machines are just another level of quality and reliability.
Absolutely, just a finer resolution. You can produce much more crisp parts.
Yeah, that's a great guide, and we've got. I was having a good read about your Dual-Extrusion for 3D printing, because it's not just a matter of loading up a second material, is it? There's a couple of ideas that go into that decision-making process. So this is a tool head. If in an Ultimaker machine, you've got a print core on the left here, so that's print core 1 and that's print core 2.
Yep.
And at the moment, it looks like this one has AA.4 fitted and BB.4. So AA typically used for like more structural type materials, and then BB for things like PVA and stuff like that. But give us a bit of a walkthrough with this guide.
Yeah, so the special thing about the S5 and the S3 is they come stock standard with dual extrusion. So dual extrusion really means you can print 2 different materials during the singular print. So that gives an advantage because you can create much better support structures with a PVA material, like a breakaway material. So that's a cool thing you can do with it. And the PVA and breakaway material usually operates very well with other materials. That's almost guaranteed. There are some materials where it's a little bit more finicky with. But you can also print things like nylon together with PLA. So you can end up with a much more spongy material and a more firm material. So you can end up like kind of shocks. You can make little shock systems. It opens up just a world of opportunities of things you can make. And it's also worth noting with the PVA, because when you dunk it into water, it will be absorbed. It gives you the opportunity to make the strongest, sturdiest supports that you can, and you can pack them in really densely, and you can just make objects that you wouldn't be able to make previously.
Yeah, so like those geometries that would be otherwise not printable, think like not just like the letter T that has overhangs on the upper part, but like engine blocks and things like that have geometries within geometries that need supports. Something like PVA will give you the ability to be able to print things like that, leave it in water for a little while. But when it is in water, I guess some things that have worked well for us here, making sure the water is slightly heated, somewhere between 25 and 30 degrees helps accelerate the dissolving process.
Giving it a little stir as well, those kind of things helps advance the process of it being absorbed by the water.
Yeah, we found a very low cost approach is just getting the Kmart fish tank and getting a heater in there. It comes in the same kit along with the little pump, and that's enough to both have a good volume of water, keep it warm, and just add a little bit of agitation throughout that enclosure or that container of water. And that all together, I think it's about $30 all up. Great combination. You can basically halve or 1/3 the time that it takes to remove that PVA in complex prints.
PVA is definitely poisonous to fish though, so you can't do an aquarium and an absorbing station.
Yeah. No, that's great. That's a good guide.
Yeah. So it's also worth noting that different plastics which have really different material properties to other plastics, they won't bond together as well as normally expected. Well, like they just won't bond together as well. So it's best engineering practice to bond materials that have similar properties together.
Yep.
Yep.
That's great. So, well, we almost could have started here. This is another guide that you've done recently. So, the Ultimaker 3D printer material guide, and this is a cracker. Like I really like this.
I'm glad you say so.
Yeah, well, it's a great guide. Like
Yeah.
I've bookmarked this for sure. So at the top here we've got the material types, and from here you can just drive down to any one of these conversations that Tim has done a bit of a deep dive about the material, what it's good for, what it's not good for, how to find the safety data sheet, the technical data sheet as well. But quite importantly, this chart, mate, this chart is great.
I'm so glad you say. Yeah.
So Tim's gone to all the effort of going through the technical data sheets and pulling out the metrics that matter most.
The juicy parts.
Yeah.
The parts that you need to know about.
So here's the lineup of Ultimaker materials, and then we've got metrics for, say, tensile strength, elongation, impact resistance, melting temperature, glass transition, and the list goes on. And this is quite helpful in picking a material that would be better suited coming out of just a prototype, right? You're looking at how it's going to be used in the real world for a long while, and lining up some of those properties alongside the material type.
The materials like CPE and the materials like PP, that kind of stuff is so strong. It will last a long time. It's UV resistant. You can be out in the weather. This has the capacity to make really practical components, pieces that will last for years.
A phrase that comes to mind is like functional prototyping. And as you make your way down this list, this is where those quick conversations are about each of those materials, and really useful. Towards the very bottom, we have a list of definitions. If you're wondering what any of these definitions are, Tim's gone ahead and created some great little extracts on what they are.
Yeah.
But here it is, like the collated collection of all the safety and tech data sheets in one zip file. So that's a handy one to be able to just have quick access to, and we'll update that as time goes by if there's anything new that happens in the Ultimaker industry. Righto. Well, oh hi, g'day. Got another hello from on YouTube. I'll put that up here. There we go.
Hope you're going well.
Cheers, mate.
Yeah.
And let me send this one through as well. There's another one. Hi, thank you.
Rock on, guys.
So a conversation that that does continue to come up in the maker industry around the Raspberry Pi 4 is a bit of a glitch with the HDMI or the monitor not working. And it's often thought that it's a fault of the Raspberry Pi not working, but there are a lot of different HDMI devices out in the wild. Like we've got a few monitors here. There's probably there are literally 3 different brands of monitors in this room. Different TV types, just so many different people's interpretations of the HDMI standard. So while Raspberry Pi have gone to their best effort to make sure it works with everything, we've got this handy guide by Owen to go in and edit the config file on your Raspberry Pi and add these settings. And this is like a sure way to make sure that the Raspberry Pi 4 will work with that display. You know, if this doesn't work, then you may as well go further down the rabbit hole and start having a look at like the connector, the lead itself, and the connectors on the lead.
Yeah, that's usually the first thing that I would look at when it comes to HDMI problems. If
you've got another Raspberry Pi, which a lot of makers do, it's always handy just to swap that SD card over and make sure it boots fine in another Raspberry Pi. And if it does boot fine there, but it's not booting fine in your Pi 4, chances are it just needs to be updated, because an old Raspberry Pi version of Raspbian often won't work on the newer boards. So just follow the update guide on the Raspberry Pi website. All right, well that's some recent guides. There's many others, but we'll mosey over to the forum, hey, and have a quick look around. Big shout out to Robin. So I doubt Robin's watching this because this is like our first live stream, but but Robin has been helping out heaps on the forum recently. So thank you. Like it's really well received. There's a couple of little holes here. So we've got this question. I've got the Adafruit. Oh, hi guys. Can anyone give me more designs to code NeoPixel ring lights. So it sounds like you're looking for some more code on how to use NeoPixels. NeoPixels being the trade name of RGB or addressable RGB LEDs by Adafruit. They've got great guides, and anything NeoPixels, just Google NeoPixel Adafruit, and it's just going to work. Chances are those NeoPixel rings are often WS2812s, and if that's the case, you can also use, and we've put together a quick guide on our website for WS2812 Arduino. So if I throw that into our search, I ought to be able to find, if I can get my search query right, here we go. So we've got a couple of different guides for, and I've got 2 spelling errors there, and now we've got console open. There we go. So let me find the one for Arduino. I have to go on the extended results because it's not coming up in the live search. And here it is.
Nice.
So WS2812 NeoPixel addressable LEDs Arduino Kickstart guide. So in this guide, Michael has put together a great bare minimum boilerplate for working with WS2812 LEDs. So this is the bare minimum you need to power them up. And even though this is a strip, if you were using the NeoPixel rings, same. You just have to define inside the code how many LEDs are in that series, and have at it. Start remixing this code, experimenting with it. If you got the LEDs short, it'll only go so far, and then the rest of the LEDs won't turn on. If you've gone too far, you'll just see the tail of the pattern keep running over the top. Like you'll know if you haven't configured it properly. But this is the bare minimum code, and definitely take a look at this video as well to help you through that. So I'll post that as a forum comment in here so that you've got easy access to it. And I'll just head back over to...
If you take the time to look online as well, there's lots of different code you can use for, say, you have a little device that picks up the sound or the frequency that's being produced, and then the NeoPixels can dance with the music, if you know what I mean. There's so much variety you can do when it comes to LEDs and how you want them to produce light. Yeah.
Nice. And so another one down here, tower mount enclosure parts. So Clint asks, hi, regarding the tower mount enclosure 10X Raspberry Pi, some of the packing list items available for purchase or easily obtainable from Bunnings, if you've misplaced them. So it looks like you're chasing a couple of bits and pieces, Clint. Looks like you've lost a few bits and pieces by the looks of things. Oh, you got another one here. A message here from Cosmic. It's a hello from the Gold Coast. Got to get that up in the mix.
Very cool.
Let me figure out how to internet. There we go.
Nice.
So shout out to Cosmic on YouTube. Just discovered that we're live at the moment. Sure are. Thank you. So coming back to Clint on the forum, these bits and pieces are pretty common. So it's a bit tricky though. Common depends on like what your experience is in maker industry. If you have easy access to parts like this. But here we're looking at some standoffs. So standoffs, we've got like bits and pieces ourselves, but I haven't really found those at Bunnings or a place like that. So
no, neither.
Yeah, standoffs. No, I think that's more of an us style thing. The screws for the top plate, absolutely. Like you're just looking at either the 3mm screws for the standoffs that keep building it up. And for those that are wondering what this tower mount is, let me show you. So I'll bring it up here. In fact, let's get the 10 stacker in the mix. So this is a tower mount. So you've got multiple Raspberry Pis. You don't have to have all 10. You could just have 2, and then make that top one where it caps off. Basically, the screws at the very top are where this tower mount goes up to, and so it could just be 1 or it could be 10 in this case. We also have a smaller one that does about half the number of layers. But you can see here that some of these bits and pieces would be common, but others would not be. And Clint has laid them all out here. So the dome nuts for the feet, they're a little bit hard to find. that's probably a bit tricky. Maybe you've got a specialist like a fastener shop nearby at a wholesaler, and these M2, M4s, sorry, M2 nuts and bolts, no problems, and acrylic spacers. Well, we just happen to have a little piece of the tower mount that's not used during the production. So this little part that runs up the top here, as I move my mouse around this edge, that's where we position the 4 spacers, so that hey, we just figured it'd be nice to get the Raspberry Pi up a little bit. So we found, you know, that was a win-win. It was either going to be waste material or we can do something more meaningful with it.
Yeah.
But arguably, you don't need the spacers if you've just got you know, M2.5 screws. Probably nylon's best that go long enough. Then the Raspberry Pi can just be mounted directly to the acrylic base plate.
Yep.
So if you have a laser cutter, stuff like this is pretty easy to do. Otherwise, might be able to 3D print a bunch of plates up and find some bits and pieces from specialty fasteners and give it a go.
If you got your own acrylic, I find it shares a lot of properties with like wood, so you can like use sandpaper on it. You can cut it with a hacksaw, those kind of things. You can also do it like that with acrylic. Yeah, so you can make acrylic spacers yourself.
Nice. And there was one more at the top here. 12 POE injection for POE camera. So Cameron asks, I am looking at setting up a high-vision camera on a pole using a Ubiquity nanostation solar panel, 12 to 24 volt PoE for the nanostation and battery, of course, but I'm looking for a cable that can insert 12 volts into so that I only have to run one cable to the camera and use the PoE port. So I'm pretty sure we have a little PoE adapter that will basically accept that configuration. Look, I'm going to have a good dive, Cameron. I'm going to have a good dive through the catalog. There's only a few tens of thousand products, but I know my way around it. I swim in that pond regularly, so I'll see what I can find, and I'll copy you in with anything that might be helpful. Righto. Well,
very swell. Let's
head over to say maybe some recent projects. So for those that are just joining, you know, welcome. This is our first live stream, and it's Makers Meet, so it's going to be at least once a week, maybe twice, depending on the reception for it and how much we've got to get through. So I'd say we'll stay tuned because it'll definitely be back.
Yeah.
Where we've talked about a couple of things, what Tim's been up to, our virtual workshops that are coming up, and if you're not on our newsletter already, you know, mosey over to the Core Electronics website. Scroll right down to the bottom, depending on what page you're on. In fact, it's on every single page, and you can sign up for Maker Mail down the bottom, and you'll be able to get that invitation to those virtual workshops when that mail out goes out. We've just made our way over to the project section on our website. People, you can share projects with Core Electronics. We'll give you like a store credit to do so. And it's a great way to sort of put some polish on a whole lot of work, right? Is to make sure you take photos during the build. You know, they're hard to go back and get, aren't they?
Yeah.
But it's great to see some projects that have made their way through.
Such a good platform to share.
Yep. So this one here, we have a smart mirror, and so Uscompuff. Hard to pronounce, but there we go. This is great. Like I really like this the smart mirror, and has gone to a lot of effort to show the build. And this is a serious smart mirror. Like, and there's some great software out there for Raspberry Pi, you know, that's available, ready to rumble, to help make this like a successful project, because sometimes that's a big deal. Like, you know, I'm not going to build a rocket ship because there's, you know, something might go wrong.
Absolutely.
But a smart mirror, a little bit risky, but and lots of lessons learned. But having a look at how other people solved problems such as this is just fantastic.
Yep.
And so there's actually a great little video here of where the inspiration came from, and also like the build process. So some lessons learned over material and how to get that reflective look and feel just right. So, you know, there's code there to make sure that it powers up correctly at the beginning, and you know, spends a bit of time going through how to configure different parts of that display for the calendar, weather, and the schedule. So that's a great project. Thanks for sharing it.
Such a nice combination of both electronics and materials and programming all coming together. That's really cool.
Yep.
That's a really cool project.
Yep, definitely. Righto, so now we've got a DIY weather station with Raspberry Pi. This is quite nice, so that it's a project that has a little bit of everything. You've got a Raspberry Pi plus parts. So this is like the classic weather station project, but in a Raspberry Pi format. Some of the modules and gear that's used here. That I've just got a message here on YouTube. Let's bring this over. That who is Core Electronics? Well, we're a team of makers in Newcastle in Australia that are just in it. Like, we're in the maker industry. We've held hundreds of workshops here locally in Newcastle over the years. Free workshops for people to come in, learn something new, learn how to code, build circuits. We help schools out with some PD, and we make electronics as accessible as possible, for people around Australia. So
people who want to create.
That's it. And there's a lot going on in the maker industry. So it's nice to have somebody that's keeping their finger on the pulse and making sure that the support's there and the products are there when you're getting started on that journey. So cheers for that. Welcome. Thanks for tuning in.
Hey, Lars.
All right. So this Raspberry Pi weather station. What's quite nice about this is a little iOS app called PWS Monitor, where you can view all your data that's coming through from the Raspberry Pi.
Yeah.
So if you're interested in, and one of the really cool things about projects is being able to look at how other people solved problems, because you might not follow the same project, but you may glean into this experience and take the bits and pieces that you thought were clever or useful to build and remix your own project. And that's the maker spirit right there. So
what a brilliant setup.
Yeah, that's
so
quite
cool.
that is a serious setup.
Yeah.
Having the stand up there like that, and
you could sell those.
Yeah, well, I don't know, that stand, you could probably get those at antenna type shops. Not easy to find. Like, we had to get something similar for our LoRaWAN antenna, so we put up a LoRaWAN antenna out the front of our building, and we wanted to get it as high as we could without breaking any rules. So we basically got the biggest one of these that we could buy on the internet. And this project box, nothing but appreciation for a project box. And I like the way that he's chosen the clear top on that, so you can see what's going on.
Absolutely, admire it.
Yep, and got the proto board in there, a bit of light soldering and some headers.
Yep. And
perfect. If it works, it's perfect. Great build. And here's a close up of what's happening underneath the hood. So yeah, the proto shield, the breaking out that little IC and some wiring, and of course,
he's so beautifully organized.
Yeah,
such a good project.
And like every project, there's a couple of to-dos. So there's a couple of things to work through. But thanks a lot for sharing. It's a great build. Like, weather stations are just a great getting started into. It's not so much getting started. It's like a next level project into electronics, but you cover off on just so many different bits and pieces along the way.
Yeah.
And so thanks a lot, Tom, for sharing that project. Okay, so we've got a 433 megahertz radio connected pool thermometer. Wow, nice.
Yeah.
I often wonder about this. Like, we put a cover on. We got a little pool at home, and I put a cover over the top of it. And I was curious if it was effective or not. So I had like an analog temperature sensor floating around in there. But I tell you what, it was. I would have loved to have been able to see like the heat curve and trend throughout the day.
If it was being recorded.
Yeah, without the cover
time.
and with the cover. So this is something that I should definitely look further into just to see how it's going. Like, if I need to leave it on all week or just leave it on for a few days a week. It saves the trip out to the backyard every time you want to have a look at that data. So here it looks like he's using
classic
an Adafruit feather of some sort. Hey, we got another hello from the internet. There we go. Darren. G'day, Darren.
Hey, Darren.
So Darren asks, hi guys, over in the UK, host a extracurricular maker club in a college. Would be great to tie it to tie up somehow. Keep up the good work. Great. Cheers, Darren, and great work.
Cheers,
It's nice to hear. The maker industry is often powered by maker advocates that are just a little bit more excited than average. That keep that continuity there, and it's great to see like those experiences reciprocate into classrooms and educators, because nothing really beats that project approach, does it?
Yeah, nothing does. Yeah.
Coming up with an idea, following it through, going through, like crossing every hurdle through that project. It's great to see. So
it's a human experience too. Yeah, worldwide. Cheers, Darren.
Righto. So on this side of town, I was just trying to find. Here we go. It's an Adafruit Feather 32U4 with a wireless radio on board, and quite a nice little device actually, because you've got this pretty quick microcontroller, or it's more like a microprocessor. It's a very decent the 32U4. It does the job, and then you've got this wireless module as well on the same board, and it's just nice and low tech. It's 433 megahertz. You don't need to spin up some 802.11 stack or anything. It's just sending data down one pin, and it transmits and it gets the job done.
Yeah.
Which for most projects is perfect if it just needs a little bit of wireless connectivity. So I'd say with this project would probably have yes. So looks like we're using a like a controller and gateway type setup, and between a Raspberry Pi and the Arduino Uno, and like a great build. And this is the chart that I'm talking about.
Yeah.
Like I would have loved to have had this chart when I put that pool cover on, because I'm like, I just don't even know if it's worth it or what's happening. But in the aggregate, I think it went up by about 6 degrees, and it's a very low cost free way to work with it. It's got another message here on YouTube. Doing a great job. Keep up the good work. Thanks,
Cheers.
mate.
Cheers, buddy.
Righto, on to another project. Hey, there's a couple here that are fairly recent. Oh, this is a beefy mechatronics project if ever I've seen one. So the articulated Mule. So this started off with I remember having a chat with his handle here is Zonard. I think I've got that right. We had a good chat about the beginnings of this project, and then it just grew. So it's turned into, so he got inspiration from these mules, which were used to work with kegs and like heavy lifting type projects, and he was able to get a couple of these for free, and he sort of repurposed them for like experimentation and project building. Yeah. So like a really strong frame to work with, like seriously strong frame. And then adding some motion and some smarts to this project. So and this began, that's right. This began with the Little Bits droid kit as inspiration. So Little Bits had a droid kit. If you're not familiar with Little Bits, little magnet modules that clip together, and you build this bigger droid. And so that was great to see this project come together, and as inspiration from it, for something so simple, so novel. Into what is some pretty beefy systems going on here.
That's a big motor.
Yep. I mean, look at this thing.
Oh,
yeah.
You can't buy RC cars like that.
Yep. That's it. Got to
make them yourself.
Another message here. Why is the stream at 3 a.m.?
Oh, Vikram.
Well, it is currently 5:12 here in Newcastle, Australia. So hello and good morning. I hope you've started your day fresh. Why are you up at 3 a.m.? But credit to you for getting up early and getting at it. But yeah, we are in Newcastle, Australia. So thanks for dialing in. And this is our first live stream. Great. So, this Mule, it's such a build, and
I'd love to see it in person.
It's just the beginnings of it. So this is like the frame of this project, and it's just going to keep getting bigger and better, undoubtedly.
Yeah.
So it'd be great to see the continuity of this project and what happens next. Oh, we should have set something like this up for this very experience.
Yeah, it would have been fun.
Yeah.
Yeah.
Right. So Ashish has built a great YouTube desktop notifier. This is a really well documented project. It could be repurposed for other things as well.
So many other things.
Yeah, and you can just see how good this simple novel type creative approaches of like this hand cut out design for the YouTube play symbol, some 7-segment displays for the number of subscribers and the views, and how did this all come about? So Ashish is a YouTuber, so builds lots of projects and does stuff, and was kind enough to share this project with us, and I really appreciate it because it's a great build. You definitely have to watch this video if you haven't seen it, because he's done a really good job at documenting the videography process of the project itself. And these are the bits and pieces that were needed to build it. And check out this scroll bar. I don't know if you can see the scroll bar very well on your screen, but it is not very big. So that no stone left unturned in this project. As you make your way through, really well documented.
Wow, look at all
talked about the libraries, how to connect the Wi-Fi, how to connect to YouTube on the on the device itself, building the timber frame, and I love that. It didn't have to be a 3D printed frame or anything. Grabbing some timber from around the house, cutting it up, nailing it together. It's a really nice crafty approach to getting a project done.
Putting the soul in.
That's right. And here's the source code. So you would change your SSID and password for your Wi-Fi. You would set up your Google Apps API and your channel ID. And I'm sure you didn't have to blank that out because channel IDs are public to begin with. And by the end of this project, if you follow that step by step, you end up with something that looks like this. Just a really nice handmade thing that's connected to the internet.
Clean.
It's really nice.
Just clean.
We should probably just throw one on the back there somewhere.
That would be fun, wouldn't it?
Maybe figure out a way.
Yeah.
Righto. And we may as well. There's a couple of others, but geez, we've been rolling
going
on for a while,
haven't we?
Yeah.
Hopefully everyone's having fun. Yeah.
So chances are you're tied up in some way at home. You've got a bit of time on your hands. You're looking for something other than Netflix to do. As am I. So we thought we'd just find 2 kits that might keep people entertained. Chances are you've got a friend or family that will have something similar that you can borrow if you can drop it off at the front and maintain all the rules. But I guess the first one here is like an Arduino kit. So something like this, fairly low cost, and this is the beginner kit for Arduino. If I can open these little tabs, there we go.
That's a sturdy box as well.
It is sturdy. So you get a bunch of these cards for working with different projects. So each project will get progressively more difficult, and you're also learning other things about electronics. So it's like pillar education where. Something you've learnt about controlling an LED and using that resistor can be used in other parts of this project. And here we're working with servos to a light dimmer and some other bits and pieces. So these cards are handy for building the project circuitry. And this is the list of parts that it comes with. A bit hard to see on that camera, but there's a lot of bits and pieces. It is in dual language, so everything's in both English and Chinese, but most things are these days from that corridor. And parts really well identified, lots of bits and pieces, so you can build those projects. And the guides are available, and I'll just bring it up here on this screen. And this is linked on the DF Robot product page as well. If you're not in Australia, you can get it from DF Robot directly. And otherwise, you can find it at Core. But you can find all of these guides and tutorials step by step with the source code and the diagrams. And that's going to be like a really great way to get into DIY electronics.
It's to give you the building blocks, so that way when you have your big project that you really want to do, you already have all the knowledge compacted and easily accessible. Yeah.
Yep. And so Arduino, great for beginners. If you haven't experienced hardware before, from a electronics point of view, a really good place to start and explore. So that is that kit. And we've got one other kit too that you'll find easily all over the world in times like these, and almost needs no introduction. But the kit itself is quite new. So it is and I'll switch over to here we go, the top cam, the Raspberry Pi 4 computer desktop kit.
Very schmick.
So
let's crack in.
Like, look at this thing.
I know.
It almost doesn't fit in the in the viewport there, but it's a monster. It's a monster of a kit. Comes with a bunch of hardware, and let's
in fact, it's a great little image.
yeah, there's a bit of an image there.
Great little image.
Yeah.
Boom, 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 boom.
Yeah, nowhere near as exciting as ripping it open. Though.
Sorry, yeah, absolutely.
Get into it. Get into it.
Break through the sheath.
Righto. So
look at that.
This is the out of box experience, and at the top, and not to be missed, and I'll go to the top camera here. You've got the SD card sitting inside here. So this has your operating system on it. It's a nifty little spot to put it. It comes in a larger adapter. So when you open this up, inside you have your the full size SD card, and then you have your micro SD card positioned inside. So that's what you'll need to put into your Raspberry Pi, and it's already got the software on it, ready to be used on your Raspberry Pi like immediately. Brilliant. You've got the Raspberry Pi 4 case, and let's see if I can get the side shot here. So yeah, there we go. So the Raspberry Pi 4 case, it comes in two pieces, so it clips up like that, and the Raspberry Pi itself will sit inside here nice and snug. No screws needed. It'll sit in there and click in place just where it has to. Some little rubber feet if it's sitting on like a slippery surface to stop it from sliding around. And yeah, you'll want to use that to make sure that you don't short circuit it or anything when it's on the bench. You obviously get or not obviously, but you get a Raspberry Pi mouse. So inside here is a Raspberry Pi mouse with a little Raspberry Pi logo on it.
Over here we have the power supply. We dive deeper into the case. We have the actual
precipice thing itself.
Raspberry Pi.
It's a Raspberry Pi 4 with 4 gig of RAM, and so this is the little computer. So I've got to get this out.
Yeah.
We got people that it almost needs no introduction, but for those that are new to electronics, because I'm going to gift this kit. Absolutely. So I have no regrets opening this. You got the USB 3, USB 2, and Ethernet, and that is 1 gig Ethernet. Like it's not just like the 3B Plus was about 300 meg, but that's true 1 gigabit. And the Raspberry Pi itself is a single board computer. So you got a quad-core processor, a bunch of RAM. So it comes with a 4 gig of RAM Raspberry Pi. Wireless module, the 40-pin GPIO. You've got the 2 HDMI ports, and I'll just try and see if I can snag that zoom. There we go. 2 HDMI ports, USB-C for power, and the TRRS connector for audio and video. But it's mostly just used for audio these days.
And it just fits in the palm of your hand.
Well, it's meant to be the size of a credit card, but it is a little bit larger if you sit them side by side.
Yeah.
But that's the Raspberry Pi. So, of course, majority of makers know what that is. For anyone that's new, looking for a way to get into computer science and explore stuff, great place to start because it's like a desktop computer. And you can turn it on, begin coding on it. It's a full graphic, window, like it's a graphic user interface like Windows. So it's easy to navigate and explore.
Yep.
Oh, and of course, you've got your 2 HDMI cables because it does support 4K dual monitor.
We even got a keyboard too.
Yeah, Raspberry Pi keyboard. And there we go. This guy. This. Like, look at this book. That is such a great intro into computer science with Raspberry Pi.
That's the semester at university right there.
And they update this regularly, so it's the content in here is solid. If you're beginning and you want to learn like visually with Scratch or something, there's lots of guides, and it's probably just worth doing in general just to explore what it's capable of. If you're sharing this with friends and family later down the track, a nice little booklet and experience to explore. But yeah, this is designed for a really wide range of age groups, and the desktop kit itself, there's a bunch of stuff in it. So,
yeah.
Well, ran a little bit over time there. We just wanted this to be like a quick 15-minute live stream test, and we'll do more of this as time goes by. But look, well, it looks like we've got another comment on YouTube here. I'll just bring that over. So Cosmic asks, will you guys be doing any test equipment reviews and demos? Well, we have already, and I'll just show you quickly where you can find some of those. So I'll make my way back over to this computer. And so if you mouse over Learn and you click on Tutorials, you'll find a collection of tutorial categories. What you're asking for is in here, test and measurement. So click on test and measurement and have a little mosey through all of these different guides. Michael, myself, Owen, and Co have been writing guides for yonks on here. And here's one that's actually Mushimeter's gone away. That was a really good product, but he just stopped. He stopped making them at some stage, which is a bit sad. But lots of relevant content in here: power supplies, oscilloscopes, arbitrary waveform generators, when to buy an MSO, a DSO, or a logic analyzer. I hope that's helpful. So again, to find that, just mouse over Learn, Tutorials, and then make your way down to the picture of the oscilloscope, which is test and measurement, and click on that.
A lot of those have videos as well.
Oh, yeah. And a bit of a part B there is looking at the Rigol 1202ZE 2-channel 200 megahertz is what you're currently thinking about. Look, my tip would be to go with one of the 4-channel scopes, and I'll just switch over to that category. So test equipment, and here we go, the 1054Z, a very good contender, but I'll just go to the rest of them here. Now, the 1054Z is a 4-channel scope, costs $710 in Australia, and so does the 1202 200 megahertz. Now, the 1054Z can be upgraded to well, there's even conversations on how to do it in clever ways from 50 megahertz to 100 megahertz. So you can just Google that and explore what's possible with the 1054Z. But it's definitely really good value having those 4 channels if you need them. Now, if 200 megahertz does have like a bit of a decision point on that oscilloscope, then you can't beat the new ZE series. So go the 1202. It is like a generational leap forward in terms of the front end, and you'll find that spec on spec, it will be a much better product. But I personally would prefer the benefit of 4 channels, so I can follow a signal through a circuit board or a design, and just make sure I can witness that it's working the way I expect it to.
Yep.
And a 2-channel scope, you can do that, but you're limited to just 2 test points along the way. So I hope that helps, and I hope that helps, Cosmic. And just before we go, one more quick question, it looks like. So Homan Colas, explain how Raspberry Pi works. Well, it's a single board computer, need an operating system plugged into it. Let's go to the top-down screen here. Need to plug in your little SD card into that slot, connect the power, connect your monitor, connect your keyboard and mouse.
Yep.
And it's like using a laptop or a computer. Off you go. It's going to boot up into a Windows environment, and you can start using it like a desktop machine. More interestingly, with the Raspberry Pi 4, it's a genuine desktop computer. You can open up tabs on it, surf the internet, watch YouTube.
If you've got experience using Windows, you'll just hit the ground running as soon as you plug it in.
Really easy. I hope that helps. So that's about a wrap. We covered a bit of ground.
Yeah, we did. I'm pretty happy with how this is all going so far. I hope you guys are too.
I didn't kill the stream at any time, which is
there's no fires.
That's one measure of success. And stay tuned. We'll sort of mosey in the afternoons. If you've got any ideas, shoot us an email. Head over to our forum. So make your way over here, mouse over support, click on forum. Feel free to ask questions. Like hit the login button, and that changes to post a topic. We're here to help. We're full-time makers, and yeah, thanks for tuning in, everybody.
Yeah. Hopefully see you guys again.
Yeah, thank you.